Okay, Mr. Baumer here, and I want to thank you for your hard work during Unit 8, which was all about factoring. All right, that skill is going to be important as we get into Unit 9 here. One of the ways we're going to solve, and Unit 9 is all about, well, there's the word right here, quadratic functions. All right, one of the ways we're going to solve quadratic functions is by factoring. All right, it's actually the most efficient way to solve quadratic functions. So those of you that have gotten very good at factoring, that'll pay off for you in this unit. But while you're writing down the objective of this lesson at the bottom of your paper, all right, student will be able to identify quadratic functions, determine minimum or maximum, and identify domain and range. All right, we're really getting in now to, in terms of Algebra 1, our second family of functions. The first family of functions we dealt with was linear functions. All right, we learned how to solve linear equations. We learned how to graph lines and things related to that. All right, even inequalities in our case were linear inequalities. All right, but now we're going to get into this family called quadratics, and we have to learn how to graph them. We have to learn how to solve quadratic equations. We have to know how to write and apply story problems to situations that lend themselves to using this quadratic family of functions. All right, so it's a tough unit. All right, it's a tough unit, but all of you can do it. All right, so let's focus here. So let's get to this first page here. Hopefully you've written down the objective. Our first thing we need to be able to do is, hey, when am I working with a quadratic function? All right, how do I know it's not a linear function? How do I recognize it as being a quadratic function? And that's where we start over here. So I want to draw your attention over here to the background explanation area. I'm going to make it a little bigger over here. Now, what we're going to do here is we're going to look at three different situations. We want to be able to identify when we're working with a quadratic, all right? And we want to be able to identify that if I show you a graph. We also want to be able to identify that if I show you just an equation. And we also want to be able to say, hey, if I just look at a table of values, I want to be able to tell this is a quadratic. And there's different tests we apply. So let's first talk about, if I give you a graph, how will you know it's a quadratic? Well, is it U-shaped, all right? Is it U-shaped? Is it this thing in math we call a parabola? If it is, then we're dealing with a quadratic function. Now, what if I just give you the equation and say, hey, is this a quadratic function, or is this a quadratic equation? Well, the issue becomes, after we get y alone, is there an x squared? Right? Linear functions, which we've dealt with most of the year, are degree 1. That's a term you'll remember from Unit 7, all right, where we talked about the degree of polynomials. Well, quadratics are degree 2 right here. All right, so when we're dealing with x squareds, we're dealing with quadratic. And now the new one, this is a completely new situation for you guys, is to be able to look at a table of values and say, is this quadratic? All right, I won't have the equation, I won't have the graph, but I'm just going to look at a table of values. I want to determine, is this a quadratic? Now, let's practice that here for a second, because we're going to look for what's called the second difference, and that's a complete new term to you guys. So what if we had y equals x squared? Well, one thing is, we could graph this, and we'd see that it forms a parabola. Looking at the equation, it has an x squared, so we know it's a quadratic. But what if we were just given the table of values? How could we determine whether it was a quadratic? All right, because these same three tests have to generate the same answer, meaning yes, they're quadratics, or no, they're not. So what if we just pick some values here? Let's do 0, 1, 2, 3, and 4. All right, and then we're running these values through this function right here. So 0 squared, well, 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And 4 squared is 16. Now, how we determine what type of function this is we can look at these things called first difference, second difference, and even third difference, but we're not there yet. Well, what do you mean, Mr. Baumer, by saying the first difference? Well, what's the difference between these numbers right here? What's 1 minus 0? Well, 1 minus 0 is 1. Well, what's 4 minus 1? That's 3. 9 minus 4, that's 5. 16 minus 9, that's 7. Now you'll notice here that the first difference, this is what's called the first difference, it's not a constant number, it's always changing. If this were always the same number, that would mean it's linear. but it's not. So let's look at the next one. Let's look at the next round of differences, if you will. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. Now, because this second difference is constant, that's what makes this table of values a quadratic. All right. So just looking at a table of values, we can determine whether it's quadratic. Now let's try and apply these three tests. All right. The second difference, looking at a table of values. The is there an x squared, looking at an equation, and the is it a parabola, by looking at a graph. Those three tests. Let's try and apply those. And I know these were a little blurry on your paper because the copies came out a little weak. So let's take a second and let's write these values in. The x values are -4, -2, 0, 2, and 4. And the y values are 8, 2, 0, 2, and 8. Now, the question asks us, does this represent a quadratic function or not? Well, we have a table of values, so we have to apply the table of values test, which is we're going to look at the second difference. So if I look here, look at the difference between those numbers, these numbers, these numbers, and these numbers. Now, what is 2 minus 8? Well, 2 minus 8 is -6. 0 minus 2 is -2. 2 minus 0 is 2. And 8 minus 2 is 6. Now, this first difference is not constant. So we know it's not linear. So now we need to look a little further. About here, let's look at these differences. -2 minus -6 is 4. 2 minus -2 is also 4. And 6 minus 2 is also 4. So because this second difference is constant, it is a quadratic function. Now, let's look here. Again, let's take a second. I know these were a little blurry on your page. I apologize for that. But the numbers here, the x values are -2, -1, 0, 1, and 2. And the y values are 8, 2, 0, 2, and 8. And again, it's a table of values. So we need to look at what's called the second difference. All right? So we look at the difference here of these numbers. Now, 2 minus 8. Well, 2 minus 8 is -6. 0 minus 2, -2. 2 minus 0, we see some patterns in these numbers here, right, is 2, and 8 minus 2 is 6. Now, looking at the second difference, we have -2 minus 6 is 4. We get 4 here, and we get 4 here. And again, because this is constant, this is also a quadratic. Now, what if we're not given a table of values? What if we're just given an equation? Well, then we need to apply this test over here, which says get y alone, and then see if there's an x squared. All right, so if I were to get y alone here, I would need to move this whole term to the other side. When I do that, I get y equals -3x plus 20. Now, is that a quadratic? Hopefully, this word is jumping into your head right now. Well, why? Because it's not x squared. But more than that, isn't this y equals mx plus b? All right, which is, this is linear. So this is not a quadratic function. Well, what about this one? Again, I need to get y alone. So I can either move these two over here, or it'd be a lot easier, I think, maybe. Well, we won't do that, actually. That might confuse some of you. Let's just do this. Let's just move this term and this term to the other side. Remember, when you change sides, you change signs. So we get y equals -3x squared minus 4. Now, is that a quadratic? You bet it is. Now, why? Because it's a degree 2, because we have an x squared. All right, so there we've kind of looked at how do we determine if something's a quadratic. Now, let's look at the next page. How do we graph quadratics? Well, let's look over here in the background explanation area. It says we can graph any type of function by making a table of values. All right, we pick the x values, and then we calculate the corresponding y values. All right, now we're only going to do the first one on this page, and then we'll practice the other ones in class. But you need to add a squared right here. That was missing from your page. I apologize for that. So this first function is y equals 2x squared. And we picked some x values, -2, -1, 0, 1, and 2. And now let's generate some y values. So this, coming back to August 21st, which you've heard me mention many times, is 2 times -2 squared. Well, -2 squared, -2 squared is a positive 4 times 2 gives us a value of 8. We're going to do the same kind of thing with -1. -1 squared is positive 1 times 2 is 2. Now, 0 squared is 0, and times 2 is still going to give us 0. Now 1, that's 2 times 1 squared. Well, 1 squared is 2, right? 1 squared is 2 times 2. I'm sorry, over here I messed that one up, right? -1 squared is, no, 1 squared, I'm sorry, is 1 times 2 equals 2, all right? Now this last one, 2 times 2 squared. Well, 2 squared is 4 times 2 equals 8. All right, so we have 5 ordered pairs to plot here. -2, 8. So that's -2 and going all the way up to 8. -1, 2. We have 0, 0. We have 1, 2. And we have 2, 8. Now, if we draw a relatively smooth curve through those, connecting those points, the question is, hey, does that form a parabola? Yes, it does. All right, and it clearly should because it's a quadratic. But that's one way. We'll learn later in the unit some shortcuts for graphing these, but I wanted you to at least practice. Remember, we can graph any type of function by making a table of values. We pick the x values, we generate the y values, we plot the points. All right, so these next two problems we'll practice in class. So let's actually go on to the next page, which says, hey, which direction will this parabola open? Now, remember back to this thing in our linear unit, which was kind of a starting point to, hey, before I even went to graph a line, did I think about which direction it should go? Well, we kind of have something similar here, all right? Now, we're used to this being standard form of a quadratic. We were doing that when we were doing the factoring unit, which is we were putting it in that form and then putting AC up here and B here, all right, for those trinomials. Well, if we can get our quadratic into this form, then all we need to really do is look at the value of A. The value of A. Because when A is positive, we're going to open up. So right here is important. And when A is negative, we're going to open down. So right here, this is y equals ax squared plus 0x plus 0. All right, those are unnecessary. But the value of A here is 4. Now that's positive, so it's going to open up. Now what about this one? You may look at that and say, wait a minute, A is 2. And you got to be careful there because you have to get y alone. So I need to move this to the other side. So to get it in standard form, I really have this. Y equals -2x squared plus 5, in which case the value of A is -2. So this is going to open down. All right? Now here, well, what's that f of x thing? Remember, that's just the same as y. So we have y equals -x minus 4x squared. Now, what is A? Careful, A isn't the first number there. A is this number right here. It's the coefficient of the quadratic term. So A is actually -4, which means the parabola, if we graphed it, would open down. And the next one, well, I would need to move this to the other side. So I'd end up with y equals 5x squared, a positive 2x, and a minus 6. Now in this case, A is 5. So this parabola is opening up. All right, so when we look at a function, even before we go to graph it, we want to have a sense of, is it going to open up or is it going to open down? Now, let's look at this idea of vertexes. All right, vertex just means a turning point. So right here is clearly the turning point. All right, well, what is the vertex? What is that ordered pair? That's 1, 5. All right, and we could pick out the vertexes. Why don't you do that? Why don't you go ahead and pick out those vertexes? And don't worry about the maximum or minimum, but I do want you to pick out the vertexes on these 4 problems. And this last page we'll talk about when we get into class. So we will see you tomorrow and look forward to the quadratic unit. Thanks.